Good day, everyone. And once again, we are back together and we're looking at the resultant of two forces. If you haven't subscribed, please just make sure that you're part of the family. And of course, you're more than welcome, rather, to get in touch with us. Our email address is info@mlungisinkosi.co.za, and you can check out our website www.mlungisinkosi.co.za. All right, so we've already gone through the first parts of vectors in two dimensions, and today we're just going to focus solely on looking at the resultant of two forces when the triangle is not a 90-degree triangle, okay? So in this case, let's just look at the first thing that we have to learn, right? So if you have a triangle that is not 90 degrees, okay, let's just take any particular triangle, okay, and I'm going to give it a name, right? So suppose that here we've got a triangle. Let's say we've got A to B and B to C, so that's A, B, and C, right? In this case, then that means that AC would be our resultant, okay? So this would be the resultant, okay? So I've got, a vector AB, vector BC, right? So what we normally do, ladies and gents, and I want you to please note this mathematically, right? Suppose that I am going to say to you, okay, let's give vector AB, all right, another name. Okay, let's call that, let's say it's forces, and let's call that force F1. And let's call vector BC, let's say that's our force F2, right? Do you see how vector AC would be the resultant of that? Remember, the resultant by definition, we said it's a single vector that has the same effect as two other vectors combined, right? So in this case, it means that this would be our resultant force. So this would be our resultant force, right? Now, remember when we had a 90-degree triangle, right? We could get the resultant, calculate the resultant force, right? By simply using Pythagorean theorem, the theorem of Pythagoras, and we could use trig ratios. But in this case, I want you to note what happens when we don't have trig ratios. When we don't have 90 degrees. So what we do is we're going to use the cos rule. And please, I want you to listen to me very carefully, ladies and gents. Right? So now, suppose we're given force F1 and F2, and they have given us the angle in between. We call that the included angle. Meaning, if I've got two sides and the angle between them, right? So suppose we had this angle here, let's call it theta, right? So that's angle B. How would we calculate the resultant force? So what we would simply say is, now please note, we use the cos rule, right? So the cos rule would be the resultant force squared, right? So it's the other two sides. So that's going to be F1 squared plus F2 squared. I want you to note, so in this case, it's going to be F1 and F2 squared minus 2 times F1 and F2, so the very same ones that are here, right? Multiplied by the cos of the included angle, right? So I want you to remember how to use the cos rule, right? If you've got two sides and an included angle. So ladies and gents, I want you to note, suppose that we were having a triangle, okay? I'm just going to take any triangle, say for argument's sake, there we are, we've got this triangle here, we've got two forces, all right? And let's call this one A, let's call this one B, and we've got a resultant force in that case that causes this not to be a 90-degree triangle, right? So there's our resultant force again, right? So what we would say in that case is that if we've got two sides, the two sides A and B, and the angle in between them, right? Again, well, let's call this alpha. So it means, once again, resultant force squared would be equal to a squared plus b squared minus 2 times ab, the cos of the included angle, which is angle alpha. All right, so please remember that is how the cos rule works. Okay, I just wanted to take a different type of drawing so that you could just get an appreciation for this principle. Right, now, another thing that we could use, right, if we've got more than one angle in there, suppose that we've got angle A, I'm gonna indicate that in green. Okay, so suppose we're having angle A, right, which is this guy over here, right? Let's give it a name. Let's say this is alpha, right? And you also had angle B. Right, now you can also use the sine rule. Now the sine rule you'll use under any circumstances, right, when you don't have two sides and an included angle. And this is how the sine rule simply works, right? We will simply say the resultant force. So you take the side, in fact, let me just write it in the traditional sense, okay? So we'll take the side, so I'm going to call it side AC, right? So if I take side AC, I always divide it by the sine of the angle that is opposite side AC. So what is the angle opposite that side? It's angle theta. So this is going to be divided by the sine of angle B, right? Should be equal to, now note again, it's equal to AB, side AB, right? So here's side AB on this side. What is the angle that is opposite side AB? That's angle C, right? So that's AB, the sine of angle C, okay, which is equal to, another side is BC, so that's BC divided by, what is the side opposite angle BC? That's the sine of A. Now, it would depend which sides that you are given. Of course, we're still going to explore this practically, but I do want you to remember these rules in this case. So what we would say, if I were to write it in the sense of the resultant force, so it would be the resultant force, and the angle opposite that resultant force is angle theta. So that would be over the sine of theta, which is divided by, which is equal to F2 in this case. And it would depend which one we're looking for, divided by the sine of, now what is the side, the angle opposite F2, that's sine alpha, okay? And in this case, F1, right, the angle opposite F1 is that angle C there, okay? So remember, you can also use sum of angles on a triangle, right? So I'm just going to call it angle C, or you can say 180 minus alpha plus theta, right? So that's angle C in that case. All right. Now, that is how we'd use the cos rule and the sine rule. So what I want us to do very quickly is take an exercise whereby we're going to apply these principles. All right, so let's take this example. They say we've got two forces that act on an object. Force F1 has a bearing of 25 degrees, and F2 has which is 80 newtons rather, has a bearing of 160, and they want us to calculate the resultant force, right? Okay, so let's just have a drawing. We're not going to draw it to scale. We're just having a sketch drawing so that we see what that looks like, okay? So I am going to have my reference point here, okay? I know that represents our north line. Okay, they've given us bearing, so it means we are measuring from the north line. So they tell us that F1 is 50 newtons and has a bearing of 25. Now, bearing of 25, if you really wanted me to be accurate with it, Okay, so it means that if I take my north line, okay, I'm gonna have to measure 25 degrees. Yeah, that's 90 degrees over there. Now think about it. If so it says 90 degrees, so I must measure 25 degrees from there. Okay, so in this case, where would it be? So that would be at, okay, so it's decreasing. So I'm going to say 90 minus 25. Okay, and that should give me 65, right? Okay, so I am going to measure it at 65 here. So that means that's my F1. Okay, so there's my F1 there. We said it's 50 newtons. Remember, I said I'm not drawing it to scale. Or in fact, I might as well just draw it to scale, actually. Just thinking about it. And we'll see if we get the same answer, right? So let me choose a scale. Let me say that 1 centimeter, or rather, let me say 10 millimeters, is 10 newtons. Okay, so that means 1 centimeter is essentially 10 newtons, right? Okay, so I just want to undo. Okay, let's redo that. Actually, I wanted to undo this one. All right, so I'm going to take it 65 degrees. I drew my north line there. So that would be 65 over there. Okay, there's my 65. Okay, so I said we should draw. So in this case, remember that it was 50 newtons. So I'm going to draw 5 centimeters from there. Okay, I just erased that. Okay, right, so 5 centimeters, so that would be, man, I keep making a mistake, erasing there instead of drawing. So that's 1, 2, 3, 4, and 5. So that should be my force F1. Okay, and then they said we also have force F2, which is 80 newtons, and it's at a bearing of 160. Now, if you think about it, bearing of 160, so if you think of our north line, that would be 0 over there, and we're going clockwise, so that would be 90 over there, and going a further. Now, if it has to be 160, so it means we're going a further 70 from 90. We're going a further 70 degrees down there. Okay, so in fact, what I'm going to do is I'm going to measure 70 degrees. Now, think about it. It's going to be 90 plus the 70, right? All of that will give me 160, right? So let's take our ruler. Sorry that I drew some really skew lines there. I shouldn't have. Okay, so we are going to draw from our 0 line there. We are going to have an angle of, okay, so I just want us to have an angle of, we said 70 degrees. Okay, right, so there it is there. Okay, so I'm going to draw a line. Okay, so try not to move the angle. Okay, so I'm going to have a line there, which is going to be 80 newtons, so that should be 8 centimeters. All right, just keep me in check there. So that's 1, 2, 3, 4, 5, 6, 7, and 8. All right, there we have it. Okay, right, ladies and gents, and my drawing isn't really not really the best, but nonetheless, it should get us going, right? Okay, so we have now both F1 and F2. We've drawn those. Okay, let me just try and get rid of that. Okay, so I know that we've got my I've got my F1 there. Okay, as well as F2, which is in that direction. Okay, now the resultant in this case, we will try and connect the two. Okay, now to draw the resultant from here, please, I want you to be very, very, very careful, right? Because that is a tail to tail drawing, right? So that means that the resultant will just not connect the two together just like that, right? What we could in fact do to make it a head to tail, remember we used the parallelogram method, right? So I'm gonna draw 70 degrees over there. Okay, I'm trying to get, yeah, there we go. Okay, and what I am going to do is I'm going to make, okay, a parallelogram there, and it was 80 newtons, right? So sorry about that. So that's 1, 2, 3, 4, 5, 6, 7, 8. Actually, I made it longer than it should be. So that's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, right. So that should be our, on the opposite side, our parallelogram. And all I'm going to do is just connect that as well. Okay, so there is our parallelogram over that side. Okay, so that's a tail-to-tail drawing. So this should be our resultant over there, right? So we should be able to measure how much that resultant is. Okay, I'm going to draw it in green. In that case, all you simply do is to connect those two from the two opposite ends of the real lines, the blue ones, to the imaginary lines, which are the red ones. So now we end up with, okay, the resultant force being that. Okay, so if I measure it, it's going to be 1, 2, 3, 4, 5. So that looks like 58. That looks like 58 centimeters. Okay, centimeters. So the resultant force should be, so we're going to do this via a calculation. Okay, so that should be 58 centimeters, right? Let's see what we get when we use the calculation. Okay, and of course we can always go back and check if after we've drawn it, do we get the same? And by the way, because our scale is 10 millimeters to 10 newtons, so that should be approximately 58 newtons of a force. So it means that our resultant force should be 58 newtons, right? Right, I haven't said anything about the direction. We'll come back to that and measure it for ourselves. Right, now, in this case, what happens if we were to make a calculation? So I'm going to make a, so let's suppose this is our F1, right? We said F1 is 50 newtons. So there we go. We've got 50 newtons. And I'm going to draw F2 at the tail of at the head of F1. If you want to, you can go back to that drawing where we had F2 being drawn somewhere there. And there's our F2 over there, which is 80 newtons. And in this case, what you would do is draw a parallelogram. What I've just done just now. That's how you make a head to tail drawing. And in this case, what you would do is that you'd say that is the resultant force, right? But if you wanted to make a head to tail drawing, ladies and gents, this is what it would look like. Okay, so I want to try a head to tail drawing. So every vector gets its own turn, right? So what you do is we're going to have F1, which is 50 newtons, right? And at the head of F1, I draw the tail of F2. So then what I'm going to do is say, okay, there's my bearing line again. Remember we said it's 160, so I'm going to measure it's 90 there, right? And it's going to be 160, let's say somewhere there. So I'm going to draw there is my F2, right? Okay, so there's my F2 line there. And then because it's a head to tail drawing, all right, so that's F2, which is 80 newtons, right? And so your resultant force, all you do is you connect the tail of the one to the head of the other, and so that would be our resultant there. Okay, so that would be our resultant force over there. Remember, this is not a scale drawing. Okay, so now what it does require us to do though is that we should now find the angles within the drawing. Okay, right, now you remember F1 was at a bearing of 25 degrees, right? So we know the angle in there from our north line is 25 degrees, right? So now we know that forms an angle of 25 degrees, right? So in this case, I want you to please note this. So if we were to use, now I am drawing another north line over there. So think about geometry, right? So if that's 25 degrees and that's these are parallel lines, remember these two green lines are parallel to each other. So what I would know is that they are alternating angles. These two are actually alternating angles, right? And if they are alternating angles, it means this angle over here is 25 degrees as well. I hope that makes sense, ladies and gents, that I'm not confusing you. Right, and then you've got, let me try and pick another color, right? Remember this here is 160 degrees, right? Now think about it, from in yellow, right, from here till there is 180 degrees, right? So what would make this little angle over here? I'm trying to take a different color, right? So let's take that one. What would make this little angle over here, right? So that would be 180 minus 160. So this angle inside here would actually be 20 degrees. I hope you can see that, ladies and gents, right? Okay, right. Now, in total, that means that in this drawing, okay, I've got an angle of 25 as well as an angle of 20 degrees, right? Trying to make it as neat as possible. So meaning that this angle inside here is 20 plus 25, and that would be 45 degrees. I hope that makes sense, ladies and gents, right? You can find other ways of, getting that angle there, right? Now notice what we have. We have two sides and an included angle, the angle in between them. Can we calculate the resultant force? Absolutely. So now I am going to say, right, to get the resultant force, it's going to be the resultant force squared is equal to F1 squared plus F2 squared minus 2 times F1 times F2, the cos of the included angle. In this case, because I didn't give it a name, let's just say the cos of 45 degrees, right? So let's substitute. We've got 50 squared plus 80 squared minus 2 times 50 times 80, the cos of 45. We're going to put all of this in the calculator. And by the way, just remember, to get the resultant force, we would need to take the square root of all of that. Okay, right, shall we do that quickly? So this is going to be the square root of 80 squared plus, okay, so that I don't confuse you, so that's 50 squared plus 80 squared minus 2 times 50 times 80, the cos of, we said that's 45. Okay, so we get 56.95. So that's 56.95 as our resultant. 0.95 newtons. I'm sure you can actually see how these are incredibly close. Remember, we got about 58 centimeters there. And by the way, our accuracy was really poor. Okay, I got about 58 and we got about close to 57, right? So it tells us we are not too far off. Now, the last thing that we need to do, ladies and gents, is remember, we still need to give the direction. Now, I'm going to do that in red. Remember, we're using bearing, so it means that we also need to give the direction in terms of bearing, right? So it means I have to measure this angle over here, all right? I have to be able to get that angle over there. Right, so what I'm going to do is I am going to actually use, okay, I'm trying to pick a color here. I'm actually going to try and get this angle here because I already know the little green angle is 25 degrees, right? So I'm going to try and get this angle over here so that I could get the bearing, right? So I am going to call that angle, if you don't mind, alpha, right, inside that triangle. Then I use the sine rule, right? Now for the sine rule, what do I have? I've got resultant force, I've got the angle opposite that. I'm looking for this angle, so I'm going to use the side opposite that angle. Do you get that? Right? So let me use the sides that I have, right? I've got this angle, so it's always the sine of the angle divided by the side opposite that angle, right? So for the sine of 45, I'm going to use f res, right? That's the side opposite that. But because I'm looking for this angle, I am having to use the opposite side, which is going to be f2. So I am going to say this is going to be the sine of alpha. And it doesn't matter whether you start with the side or you start with the sine of the angle. It's all the same thing as long as you keep to the same thing with the others, right? Sine of, okay, so maybe so that I don't confuse others, maybe let me start with the side. Okay, so I'm going to say the resultant force divided by the sine. What is the angle opposite that resultant force? That's angle 45 in the triangle, which is equal to, we were looking for the angle alpha. The side opposite that is f2. So this is going to be f2 divided by the sine of alpha. Right, now all we simply do is cross multiply, right? So that's going to be f res, resultant force, multiplied by the sine of alpha is equal to f2, the sine of 45 degrees, right? So we're looking for sine of alpha, so we're going to divide by resultant force on both sides. Okay, so that cancels that. So we've got F2, which was 80 newtons, sine of 45, divided by, remember the resultant force we got 56.95. Okay, so we've got F res, sine there, sine of the angle. Okay, sine of alpha, right? And all we do to get the angle, we'll say the arc sine of 80 sine 45 over 56.95. Okay, and in this case, I'm going to say arc sine of 80, the sine of 45, right? Oops. That's 80 sine of 45. Okay, and that's divided by 56.95, is it? Yeah, 0.95. I close that, and I get an angle of 83.36. 83.36. That's the angle alpha. But now let's put it in context, right? So we've got an angle of 83. Okay, so I'm trying to remove the stuff here. So this angle inside the triangle, right, is 83.36. But remember, we're going to have to express that in terms of bearing, right? And how do we express it in terms of bearing? Remember, it's from our north line going clockwise, right? So from 0 there, we know this is 25 degrees from here till there. We've got another 83.36 from there till there. So this is going to simply be, okay, so I'm going to just simply say plus 25 degrees, and that gives me 108.36, right? So it means that our resultant force, ladies and gents, our resultant force is equal to 56.95 newtons, right, at a bearing of 83.36 degrees. At a bearing rather of 103. Sorry about that. At a bearing of 103.36 degrees. So what I want us to do quickly, we've reached the end, but I just want us to kind of verify that bearing. Let's take our ruler. Okay, so you'll remember that it's measuring from 90 degrees over there. Okay, so what I'm going to do is I'm going to take it at 90. That's where it measures 0 over there. It kind of takes that as 0 degrees, right? So I'm going to measure this angle from here till that bearing there. Okay, it gives us about, is it 11, 10? Yeah, let's say, no, that's too skew. That gives us about 10 degrees, right? So in this case, it's 90 plus 10 degrees. So in this case, when we measure it, we get something like, that's about 100, ne? So that's going to be 90 plus 10. Remember, our drawing was not too accurate. So in this case, it measured 90. I'm going to do that in black from here till here, right? But it measured an additional 10 degrees from there till there. So in that case, it means it's about 100 degrees. So when we did that in scale drawing, and by the way, you'll always realize there's a discrepancy depending on your level of accuracy in that case. So when we did the scale drawing, it gave us 58 newtons, right, at a bearing of 100, okay, degrees. Okay, right, I hope that you understood that, ladies and gents. And I'm still going to be doing some more of these, and just to help you in how to understand two-dimensional vectors. Otherwise, please don't forget to subscribe, and hit like and tell as many people that Uncle is doing the most on our channel. Otherwise, from me for now, I'll see you guys next time. Shap shap.